All right, my secondary math 1 class, we are going to be continuing to talk about the Pythagorean theorem and solving for missing angles and sides of triangles. Okay, so for numbers 1 and 2, it's asking us to find the measure of each angle. Okay, so remember, we're looking for angles here, not sides. Okay, so we know that in a triangle, and just in case we need a little reminder, let's write it again. In a triangle, all 3 angles are always going to add up to 180 degrees, always. Okay, that means that these 3 angles inside here are always going to add to 180 degrees. Okay, beautiful. So let's look at number 1. Okay, so it gives us 2 angles. So 2 angles we know 38 degrees and we know 93 degrees. Okay, we don't know the third angle. Okay, this guy right here. That's what we're trying to find. Okay, so in order to find that, we are going to take 180 degrees, our total number of degrees, and subtract the 2 angles that it gives us. So 180 minus 38 minus 93, doesn't matter which order you put these 2 in, as long as you start with 180. Okay, so we can put this into a calculator if we want. So we can do 180 minus 38 minus 93, and that gives me 49. So I know that that third angle right here has to be 49 degrees. Beautiful. Okay, let's look at number 2. Okay, so the 2 angles that it gives us in number 2 are 45 degrees and 80 degrees. Okay, so we're going to take our total number of degrees, 180, and subtract the 2 degrees that it gives us, minus 80, minus 45, in order to find our third angle that we don't know, this question mark right there. Okay, so again, we can put this into a calculator. 180 minus 80 minus 45, and that is going to give me 55 degrees for that third angle. Okay, so for 1 and 2, we were simply trying to find the third angle when given 2 angles. Okay, so now in numbers 3 and 4, it's asking us to find the measure of angle A. Ooh, okay, so find the measure of angle A. Okay, so let's find angles A in 3 and 4. So we have A right here and A right there. That means we're trying to find the measure of these angles. Angle A. Okay, well notice, let's look at number 3. Notice that there are actually 2 angles with X's in them. How in the heck am I supposed to find the third angle, this angle, if I don't know 2 angles? Okay, that's okay. Instead of subtracting from 180, we can go backwards. We can take all 3 of these angles and add them to 180, okay? So we're gonna take this angle, okay, X plus 67, plus that angle, plus X plus 87, and add it to our last angle, plus 40, and that is going to give us 180 degrees. So now doing this, we can then solve for X. So a few things we have to do first. We need to combine any like terms that we see on this side with our X's. Okay, so I see that I have 2 X's. These are like terms. Okay, so 1X plus 1X is 2X. Okay, my other like terms I see are just numbers, 67 plus 87 plus 40. Okay, so let's go ahead and add those up. 67 plus 87 plus 40, and that gives me 194. Okay, and that all equals 180. Okay, same thing on that side. Okay, so we simply combined our like terms to make this side a little smaller, easier to solve for X. Okay, well now looking at this side of our equal sign, in order to get X by itself, there's like 2 things I need to get rid of. I need to get rid of this times by 2 and the plus 194. I need to get rid of the plus 194 first. Okay, and how do I do that? I'm going to subtract 194 from both sides. So I have 2x is still left over on this side. 180 minus 194, if you want to do it in a calculator, that's totally fine. Minus 194 is going to give me negative 14. Okay, well now that I have my x almost by itself, what is my very last step for getting that x by itself? What is the opposite of times by 2? We're going to divide by 2 on each side. Okay, so now I have my x is all by itself. And what is my x? What is negative 14 divided by 2? We are going to get negative 7. And that is my x for number 3. Okay, now I know it said to find the measure of angle A, but I'm actually going to make an executive decision and change that to just saying find the x or solve for x. Okay, which we did. Okay, find the x or solve for x. Okay, boom, we're done. So that's good. Okay, so let's look at number 4. Okay, so again, we're trying to solve for x. I changed it, so we don't really have to worry about angle A anymore. Okay, so just like on this one, we're going to take all 3 angles and add them to equal 180, because we cannot subtract them because there are 2 angles we don't know. Okay, so let's take our first angle, x plus 61, plus our next angle, x plus 56, and plus our last angle, 85, and that all equals 180. Okay, next step, just like in our number 3, we need to combine like terms. Make this side of our equal sign a little smaller. Okay, so I see an x here and an x here. So 1x plus 1x is going to give me 2x. Okay, I see a few numbers that I can add together. 61 plus 56 plus 85. Okay, we can do that in our calculator. 61 plus 56 plus 85. And that's going to give me plus 202. Okay, and we know that on the other side, it still equals 180. Okay, so now looking at this side of my equal sign, I need to get rid of my plus 202 first. Okay, well, the opposite of plus 202 is subtract 202. Okay, so I have 2x left over on this side. What is 180 subtract 202? You can do this in a calculator. 180 minus 202 is going to give me negative 22. Okay, we're almost done. We need to get rid of times by 2. So what is the opposite of times by 2? We are going to divide by 2. So we have x is all by itself on that side. What is negative 22 divided by 2? I get negative 11 for my x. And there we go. We solved for x. Beautiful. Okay, so on numbers 1, 2, 3, and 4, we were trying to find missing angles. We were working with the inside of our triangles. Those are the angles. Okay, for numbers 5 through 8, well, actually 5 and 6. We're not talking about 7 and 8 yet. 5 and 6, we're now trying to find the missing sides. Okay, missing side and missing side. Okay, well, in order to find missing sides of right triangles, okay, we see they both have right angles, we have to use our Pythagorean theorem. So let's go ahead and write that down again. Pythagorean theorem. Okay, well, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, and let's remind ourselves, what is a, b, and c in a right triangle? Okay, so we have our right angle. Okay, we know that the legs of our right triangle that make up this right angle, so this is a leg, that's a leg, this is our A and B side, and it doesn't really matter which is which. But remember, across from our right angle, that is called our hypotenuse. That is always our C side, always. Okay, that is the most important part right there. Okay, so looking at number 5, let's identify our sides A, B, and C, okay? So I see my two legs that make up my right angle. I'm just going to go 8 is A, B is 6, and that means C is going to be X. Okay, so now that I have my A, B, and C, I can go ahead and just plug it into my Pythagorean theorem. So A squared, my A is 8, so 8 squared, plus B squared, my B is 6, so 6 squared, equals C squared, my C is X, so X squared. Okay, well now we can start solving for X. We can figure out what that missing side is. So what is, first of all, let's do some simplifying. What is 8 squared? What is 8 times 8? That is 64, so we're just gonna write it right underneath. Plus 6 squared, but what is 6 squared? 6 times 6, 36. And we don't know what X is yet, so we can't simplify it. That has to say X squared. Okay, well now on this side, we can add these two numbers together. What is 64 plus 36? We get 100. Okay, X squared still on that side. Okay, well now my last step to getting X by itself, what is the opposite of square? Square root. So I need to square root both sides to get my X by itself. And what is the square root of 100? Or what is the number that multiplies by itself to give me 100? Okay, if you don't know off the top of your head, remember our calculators, you can do second, the little X squared button, because that is a little square root 100, and I get 10, because 10 times 10 equals 100. Okay, so we know that the square root of 100 is 10. Okay, so my missing side was 10. Okay, so on number 5, we got a really nice answer, just a whole number. That's actually called a Pythagorean triple, 8, 6, and 10. Okay, those are nice, pretty numbers. Well, on number 6, we're still going to use our Pythagorean theorem, but it might not turn out so nice. Okay, so let's first identify A, B, and C in our triangle on number 6. Okay, so we know that the two sides that make up that right angle are A and a B. I'm just going to do X is A, B is 9, and C is 14, because it's across from our right angle. Okay, so let's go ahead and plug it into our Pythagorean theorem. A squared, my A is X, so X squared, plus B squared, my B is 9, so 9 squared, equals C squared, my C is 14, so 14 squared. Okay, so let's do some simplifying. Let's start with X squared. Can we simplify X squared when we don't know what X is? No, we can't, so it just has to stay X squared. Okay, what about 9 squared? 9 times 9. We get 81. Okay, and what about 14 squared? I'm actually going to have to use my calculator for this one. Clear, 14 squared equals 196. Okay, beautiful. So now looking at this side with my X, because I need X to be by itself. What do I need to get rid of first? The square or the plus 81? We need to get rid of the plus 81 first. And how do I do that? Okay, we need to subtract 81 from both sides. Okay, subtract 81, subtract 81. We get X squared is left on this side, equals, what is 196 minus 81? Okay, well, minus 81. We get 115. Okay, we're not quite done, because what is the opposite of square? How do we get that X by itself? We're going to square root it. Square root. Okay, and what do I get for X? What is the square root of 115? Well, let's check. Okay, so second square root button, 115 equals, oh, that's a big ugly decimal. So instead of this big ugly decimal, I'm just going to keep it as the square root of 115. And there we go. Not quite as pretty as just 10, but that's how we leave it, just the square root of 115. Okay, so now for 7 and 8, we're going to have to use our Pythagorean theorem, but our answer, it's asking us to actually find the area of each triangle. Okay, this one's kind of different. So over here on the bottom corner, let's write our area. Actually, I'm going to draw an arrow over here, and let's do our area formula. The area of a triangle is this formula. 1/2 times base times height. Remember, when they're just right next to each other like that, that means they're multiplying. So 1/2 times base times height. Okay, well, let's identify what our bases and our heights are. Okay, so in number 7, we have our base is the bottom. Think base, bottom. Okay, and then our height is how tall the triangle is. So right there. Okay, so look at our base and our height. So do we have our full base? Okay, we only have this piece, which is 4, which means we're missing this piece. Okay, we're missing the rest of our base, so we're just going to call that x. So in order to find x, we have to look at this part of our triangle. Okay, just look at this half of our triangle. And we're going to identify A, B, and C, so we can find that missing side of our triangle, just like we did up here. Okay? So, and actually, I might make an executive decision here. No, let's try it. Let's try it. Okay, so let's identify A, B, and C of just this half of our triangle. Okay, so my X is A, 7 is B, and C is 11. Remember, we're just looking at this half of our triangle. Okay, so A squared, X squared, plus B squared, 7 squared, equals C squared, 11 squared. Okay, let's do some simplifying. We don't know X, so we can't simplify, so that stays X squared. We do know 7 squared. What's 7 times 7? 49. And then what is 11 squared? 11 times 11? 121. Okay. So now we have this side of our equal sign. What do I need to get rid of first, the square or the plus 49? We need to get rid of the plus 49 first. Okay, so we are going to subtract 49 from both sides. Subtract 49. Okay, we get x squared is left over here, equals, what is 121 minus 49? We can do it in a calculator. That's going to give me 72. Okay, my last step to get x by itself, the opposite of square is square root. Okay, well, what is my x? Okay, and let's look back at our instructions. So it says round intermediate values to the nearest tenth. Ooh, this means we're using a decimal. Okay, tenth and tenth. That means we actually do want the decimal. So let's use our calculators. Second square root button, 72. Okay, so it gives me this decimal, and it wants it to the nearest tenth. That means one place after my decimal. Well, if it wants it to one place, we have to look at the number after it. Okay, since this number after my first place is an 8, and that is above a 5, that turns that 4 into a 5. Okay, so our answer is x is equal to 8.5. Okay, and that's still not too scary. Okay, and actually, I am making the executive decision to just find the missing side of a triangle. Find missing side. I know I've made a lot of executive decisions today, so we don't even really need the area formula because we're not going to use it today. Okay, we might use it a little bit, but we just used our Pythagorean theorem to find our missing side. Okay, awesome job. And my last executive decision, I'm going to go ahead and just skip number 8. So that is going to be your notes for today. There's an assignment that goes with it. Nice job, you guys.